Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 8.5, Division Properties of Exponents. The division property states, for any number a and integers m and n, a raised to the m power over a raised to the nth power is equal to a raised to the m minus n. What that means is when we divide terms with like bases, we will subtract the exponents. That may not make a whole heck of a lot of sense to you yet, but after these three examples, I think it will probably make some sense. So what we're going to do is we're going to subtract the exponents, and then we're going to put whatever is left in the location of the larger exponent. So for this first example, I have x to the third over x to the fifth. Well, 5 minus 3 is 2. Because x to the fifth is larger than x to the third, I'm going to have my remaining x squared in the denominator. And because there's nothing left in the numerator, it will be 1. There's always that hidden 1 in front of exponents. All right? Let's look at number 2. I have 4 to the fifth over 4 to the third. Well, 5 minus 3 again is 2. The 2 I will raise the 4 to the second power in the location of the largest exponent, which is in the numerator. So 4 raised to the second over 1, which is just 16. Now, remembering what we did in our last section, when we multiply two variables that have exponents, we will add the exponents. So when I multiply h to the negative third times h to the sixth, what I'm going to do is take negative 3 plus 6. So I'll end up with h to the third over h to the 10th. I'm going to take 10 minus 3, which is 7. The 7, so I'll have h raised to the 7th power, will be in the denominator because I have h raised to the 10th, which is larger than h raised to the third in the denominator. So it would be 1 over h raised to the 7th. Okay? Here's some more examples. Rewrite each expression using each base only once. So again, I have m to the third over m to the 11th. 11 minus 3 will be 8. So I will have m to the 8th. Okay? But I need to put it where the largest exponent is, which is in the denominator. So 1 over m to the 8th would be my answer. On to problem number 2. I have 2 to the 7th, or 2 to the 5th over 2 to the 7th. 7 minus 5 will be 2. I need to have 2 raised to the second power. Since 2 to the 7th is larger than 2 to the 5th, and that is in the denominator, I will have 2 raised to the second power in the denominator. So my answer would be 1 over 4. Problem number 3 is very similar to the third example we did above. So I'll have k to the second over k to the fourth. 4 minus 2 would get me 2. Since k to the fourth is larger, I'm going to put k to the second power in my denominator. On to problem 4. It does not change just because I have multiple variables. We're just going to treat each variable independently. I'm going to stop writing this subtraction problems that we've been doing and just work through the problems from here on out, okay? I have a to the second and a to the sixth. Well, a to the sixth is larger. 6 minus 2 is 4, so I have a to the fourth in my denominator. I have b to the fifth and just b. Remember that if it's just a b or a variable by itself, it is raised to the first power. So b to the fifth is larger than b to the first. 5 minus 1 is 4, so I have b to the fourth. Before we continue with even the variables here, we need to simplify our fraction with numbers. Well, 6 and 18 are both divisible by 6. 6 divided by 6 would be 1, obviously. 18 divided by 6 would be 3. Now we can look at our x's. X to the 8th is larger than x to the third. X to the 8th is in our numerator, so 8 minus 3 is 5, so I have x to the 5th in the numerator. Y to the 6th is larger than y to the third. 6 minus 3 is y to the third. Again, that will go in the numerator. And then I just have this z to the 9th. There is no other z, so that will just stay. On to problem number 6. I have 2 to the 4th over 2 to the 3rd. Well, 2 to the 4th is larger than 2 to the 3rd, so that's going to stay in the numerator. 4 minus 3 is 1, so that will just be 2 in the numerator. I have d to the 5th over d to the 5th. 5 minus 5 is 0. Whenever I raise a variable to 0, it will go away. I do not need it anymore. E to the 6th over e to the 2nd. E to the 6th is obviously larger, so that's going to go in the numerator. 6 minus 2 is 4. I have f to the 8th over f to the 7th. Well, f to the 8th is larger, so it will stay in the numerator. 8 minus 7 is 1, so I can just write that as f. That would be over 1, or I could write it as 2e to the 4th f and be done. Okay? On to our quotient property. For any number a and b and integers m, n, and p, if I have a to the m over b to the n, all of that is raised to the p power. What's going to happen is my m and my p will be multiplied together. My n and my p will be multiplied together. Okay? So using the quotient property, I have x to the 3rd raised to the 5th power, so that would be x to the 15th. I have y to the 2nd raised to the 5th power, so that would be y to the 10th. This is really no different than what we did in our last unit. It just happens to be in a fraction, so we have to work through the fraction that way. Okay. The second example, I have 5 raised to the 4th power, because this is really 5 raised to the 1st. 1 times 4 is 4. Staying in my numerator, 3 times 4 is going to get me 12. Remember, this is y to the 1st, so y to the 1st raised to the 4th power. 1 times 4 is 4. Now I have to use our division property from above to figure out our y. Before I do that, though, I need to find out what 5 raised to the 4th power is. 5 raised to the 4th power is 625. I have y to the 12th over y to the 4th, so the y will stay in the numerator. 12 minus 4 is 8. All of that is over 1, or I can just write it as 625y to the 8th. Simplify each expression again. So I have 2, which is raised to the 1st power, in my numerator. 1 times 4 will be 4, over. Z is raised to the 1st power. 1 times 4 is 4, so z to the 4th. I need to figure out what 2 to the 4th power is. In this case, that is 16 over z to the 4th. And I am good there. Problem number 2. I have negative 3y squared over x to the 4th. All of that is raised to the 3rd power. So I would have negative 3 raised to the 3rd. Y squared raised to the 3rd. I'm going to take the 2 times the 3, so that would be y to the 6th. X to the 4th raised to the 3rd power. 4 times 3 would get me 12. I need to take negative 3 to the 3rd power, so negative 27. Y to the 6th over x to the 12th. The final problem is not raised to a power on the outside, so all we have to do is use our division property. So 24 over 3, that can simplify down to 8. 24 divided by 3 is 8. I have r to the 8th over r to the 6th. Well, r to the 8th is larger, so that's going to stay in my numerator. 8 minus 6 is 2. I have s to the 9th over s to the 5th. S to the 9th, again, is obviously larger, so s will stay in my numerator. 9 minus 5 is 4. Then I have t to the 5th over t to the 7th. Well, t to the 7th is larger than t to the 5th, so my t will move to the denominator. 7 minus 5 is 2, and I am done. So what you need to remember from this lesson is using the division property. If I have two variables, one in the numerator, one in the denominator, I'm going to take their exponents and subtract them. Whatever is left over will be the exponent for that variable, wherever the larger exponent was in the original problem. So if it was in the numerator, the variable will stay in the numerator. If it was in the denominator, the variable will be in the denominator with that new exponent. Using the quotient property, anytime I have anything inside of a set of parentheses raised to another power, everything inside of the set of parentheses will get that power. Then you can use the division property to figure out how to simplify it. Well, that is the end of the lesson. If you have any questions over this lesson, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.